welcome everyone to the last event in this series of philosophy public lectures. The whole intent behind the series was to kind of think of how we as a general audience think about the relationship between science and the humanities. We have science kind of intruding or helping every aspect of our lives. And sometimes in that sort of period we're living, a kind of rush, kind of just using them, and we don't stop and reflect kind of what's the impact on our lives, and the idea would be that the humanities help us do that. So we did in the first event thinking about AI and what is the promise of AI, how AI makes different mistakes than humans, and we're thinking in the first sort of event whether humans are so different from machines when they do make errors. And last time when we met, last Tuesday, we were thinking how scientists and kind of philosophers kind of think about what they do and how they communicate to the audience what they do. And one question that kept popping up in Q&A, but also in our conversation, was like, but what makes us human? You know, what's the human in the humanities? And in the Q&A, some of us dared some answers and some suggestions having to do with our emotions, having to do with our biology or bodies. Not so much about kind of our reason, because we kind of thought, oh, machines mimic that to a quite good extent. And one other sort of idea we want to explore today together, company of three wonderful philosophers, is how imagination kind of gives us kind of part of our humanity, whether it does, whether it's something special, and how imagination plays a role both in the sciences and in the arts. So I invite Adam, Fiora, and Milena today to have this conversation about what's the point of imagination? Is it just kind of secure a flight from reality, or whether we can actually sort of gather knowledge through imagination? But because I wanted to pair the science with the humanities, I wanted to start with one question that kind of focuses on the science sort of part of things, and kind of to invite our guests to kind of tell us their thoughts about whether science does require imagination at all, or other observation and reasoning is kind of enough to have science and technology. So over to you. What do you think, Adam?
Yeah, so let me, sorry, this is the light. Yeah, I think it does. I suppose the main reason that I've thought that it does is that the world in William James's phrase is a blooming, buzzing confusion. In other words, that, you know, the world's a mess. There's a lot to say about it. If you wanted to just start giving a true description of everything on this table, you'd be there quite a while if you started to list every little mark and so on. And so often when you look at what happens in the sciences, you see that what scientists have to do is not, as you might think, just describe the world as it is, but treat it as if, as you might put it, it were simpler, more idealized. So very often you get a move that you could call it imagination, or pretending that the world's a different way. So, you know, we might, if you remember back to school science classes, when you'd be, you know, you might get a spring out the store cupboard, and the teacher might say, well, can you predict for me how much it will bounce up and down if you put a lump of plasticine on it and let it go. And you've just been doing Newtonian mechanics and so on, and of course you fetch the spring out the store cupboard and it's all bent because the class before you have used it, and the bit of plasticine is all, you know, lumpy or whatever. And you think, well, where do I begin? And then of course the teacher says, well, you know, pretend that the spring is perfectly straight and it exerts a linear restoring force or what have you. Ignore the air resistance, that's too complicated. Pretend the lump of plasticine is a point mass. So before you know it, rather than trying to describe reality as it is, you're being asked to imagine a much simpler, more idealized world, and a lot of science works like that. So that's one role I think that I've been interested in, to the imagination.
What do you think, Fiora?
I completely agree. And that was, I think, so you just gave us a paradigmatic example, right, of what happens when we try to make sense of a reality that is too complex to be explained, analyzed, and understood as it is. So we need to, as we say, step out of it. And so maybe what I can contribute if we talk about imagination is to say that imagination is this ability that we have, not just to form mental images. That is one intuitive notion of imagination, right? When we think about imagination, it has the word image in it. So we think, oh, that's all about forming these pictures of alternative objects, alternative states of affairs, events, processes. But actually, imagination is more like an ability that we have to disengage from the immediate environment, right? To foresee. It may be one of its adaptive functions, we call it in the cognitive sciences, and with a view at why we evolved with these particular abilities. So perception is about getting things right as they are. So we have the senses to orientate ourselves in the environment, to know what there is, and belief is basically a way to generalize from these initial perceptions and to form categories, the concepts, right? We also have the imagination, and the imagination is not about describing reality as it is about contemplating alternative possibilities, alternative possible ways things could be. So looking at the past, what would have happened if X had been different? That might teach us something, right? Perhaps not to repeat the same mistake over and over. And for planning and thinking about the future, so foresight is an ability that we as humans in particular have developed thanks to the imagination. And so in science, of course, what we have is a deployment of this particular cognitive ability that we use since the age of 2, probably. So cognitive scientists have done some studies in trying to understand when we actually begin to learn how to imagine. So we engage in these games of pretense, children's games of pretense, and we never grow out of this ability. We just train it, let's say, to do different things depending on different purposes and goals. And in science, we do it in a specific way. We might talk about that later.
It's
but
interesting.
That's my idea.
Last time, I don't know how many of you kind of will remember from last lecture, one of our guests kind of pointed out that, children are born scientists. And now kind of Fiora is saying, children very early on are these hugely imaginative sort of creatures. I mean, I think if we probably leave children to it, we'll get kind of better fiction than, I mean by fiction, better sort of Marvel stories or the sort of thing, because there's so many things happening. But you're also sort of referring to that, the sort of, maybe we pick up on that, and maybe kind of Milena has some thoughts on kind of something special with the imagination in the sciences. Do you think there is, or do you think it's more of a continuity? So we use imagination in this multiple way, and that continues into science.
Yes, I will address your question, but just wanted to say something before I started. When we're thinking about, is there any role for humanity aspect in science, without asking this question, without seeing the connection between them, we will not understand what makes discovery possible. If we're thinking discovery is all about collecting data, and here's an algorithm, look at the evidence, you're going to infer X, and then, look at, is X confirmed or not by your observation? That's not how science works. You're never going to understand what made Einstein be interested in light, how light behaves. You're not going to understand that. You're going to leave a lot about what's interesting about science out unless you think about these kind of contexts, right? And it also brings us to think about the aim of science. Is science aiming just to produce data, or is it also there to teach us how to, employ certain tools like the imagination? Maybe there's other things that we really have the goal to achieve, such as maybe science is really beautiful and delivers a lot of aesthetic emotions in us, and that's actually where the similarity with art lies. So I'm sure we'll explore all these, but I think when I think about the role of the imagination, this is what I'm thinking about. Without it, you won't understand how science is possible, and you won't understand what's interesting about science as well, because, we presumably a lot of us started thinking that, well, I want to learn science, that's all I care about, and after a year or two of fact learning, you want to know other things as well, and you turn a little bit to do a bit of history, a little bit of, I did a little bit of history of art, to understand better how science works, right? So this is another thing. On children being imaginative and being amazingly creative little agents, and what we have in science, you know, the imagination is great, but you also have to know the constraints with which you're operating, and children are perhaps way unconstrained, right? Say, when science, you know, when you think about scientific discoveries and what was, you know, important about certain thinkers that we would say revolutionized the way we think, well, they knew their constraints really well, and they were able to then think and reconceive something, but they knew what to think about and what to re-evaluate. So in that sense, you know, it's great to cultivate imagination, but you also need to know stuff, right? Just to say it bluntly.
Yeah.
And, you know, it's great, you know, to keep that kind of inquisitiveness going on whilst you're also learning specific fields and the rules of a game, let's say, if you think science is a game.
Yeah. I mean, I think one of my favorite definitions, if you can call it that, of imagination comes from Darwin, kind of points out that, look, imagination is all about this combining these ideas and this sort of data. So it's, and kind of these new ways in kind of discovery. But Darwin also sort of points out, like other sort of big names like Aristotle and Kant, that there is a sort of element of maybe unconscious sort of at work in the imagination. Would you kind of think that that sort of philosophical tradition that emphasizes a bit that imagination kind of comes before reasoning, so comes before, is it a precondition but not really a cognitive faculty, or do you think we discovered more about imagination, so now we can have a more positive conception of it? What do you think, Fiora?
Okay.
You are nodding, so I will just pick up you.
Okay. No, so it depends on what you mean on imagination. If imagination is this ability to form mental images, so basically mental imagery is what we're talking about. Yeah. Then you do have images in perception, in belief, in imagination, in memory, so that's the relevant type, right? And there is this old idea, which is still very much alive now in contemporary cognitive science, that all the information that we use in imagination is actually information that we gather from the environment through perception and generalizations. So we have concepts that, even for mental images, they help us to form new mental images. Now, these new mental images do not come from nowhere, right? They do come from the flexible deconstruction and reconstruction of the information that we gather from the environment. Mm-hmm. So that idea is still very much with us, and all the literature on episodic memory and episodic imagination is actually working on this particular notion. Now, reasoning, it depends on what you mean by reasoning. So if reasoning is just logical inferences, you might think, well, mental images, logical inferences, they don't seem to have much to do with each other. But first of all, reasoning is broader than just inferential reasoning. We have analogical reasoning, problem solving, and that definitely can involve mental images, right? And then we have, when I talked about imagination, is this ability to contemplate alternative possibilities. Yeah. That's about states of affairs, and you can only describe them, use this as simplification, but linguistically, propositionally, right? So you have objects described as having certain properties. Yeah. And so that can come with or without mental images. It's independent of that. Reasoning in science, especially like of the kind that Adam was articulating so well before with his example, it's not just about mental images, it's about domain-specific knowledge, right? We need to know a lot in science to be able to think about the right kind of problems and the right kind of solutions. It's not that you just come with no idea of where to start from and what to do next, right? Mm-hmm. And so we have a combination of different types of reasoning, possibly different types of mental representations, imagistic, propositional. As long as you are disengaging from the direct environment, you are entering into this realm of the imagination, which of course explains a lot of the reasoning that goes on in science as well, right? Point masses, frictionless planes, all of these idealizations, they wouldn't be possible with only observation and belief. We need to be able to abstract, idealize, omit, and so to form these scenes, to contemplate these scenes, these objects as having certain features in a way that might involve also pure arguments, but about these imaginary objects, not about real ones. That would be my...
So what would you say, Adam, is kind of in this sort of continuation of like the philosophical tradition is like, so Fiora provided a very broad sort of notion of imagination. Would you kind of go with it or kind of think it needs to be a bit more constrained?
Maybe even broader in a way. I mean, one thing, so I wanted to go back to what Milena said about, kids imagining and being relatively unconstrained. And sometimes it is. I mean, you say that we never forget how to imagine things, but I certainly felt before I had children that I had sort of forgotten, and it took quite a lot of time to get back into it, when they ask you to play games and you suddenly feel as if you've got no ideas. But of course, so of course, some imagination is unconstrained, daydreaming and so on. You find yourself wandering from one thought to the next and there's no rhyme or reason to it. But I guess, one form of imaginative activity that I've thought's really interesting for understanding certain aspects of science is playing games. And of course, that is quite constrained in a way. I mean, my daughters certainly tell me if I get it wrong. If we're playing with the dollies or whatever, and I call one the wrong name, I've got it wrong. Or if I say she's asleep, and they point out that the little eyes are open, then I've got it wrong, and I'm corrected all the time. So and I suppose the reason to point that out is that the sense in which I'd want to maybe use a slightly broader notion of imagination is I think imagination is something public very often. So it involves, and that's quite important, I think, in science. So, we want to say, of course, that scientists can be right or wrong about certain things. And that means that I think that when we're talking even about imagination, we don't just mean something locked up in here. Right? So sometimes we mean, saying Dolly's asleep, baby's asleep, give us some food. These are imaginative things, rocking like this with a lump of plastic and feeling a bit daft when you do it, if you're, as I am, 40 years old. That's an imaginative thing to be doing, and anyone who looked at me doing that would think I was engaging in imagination or imaginative activities without needing to know what's happening here. Yeah. So.
Yeah. Would you?
I wanted to add that there's a long tradition, as you said, in philosophy to think that creativity and discovery in science is completely out of the blue, right? There's a lot of good reasons why that stereotype has existed, because scientists often, that's how they talk to us about it, right? Oh, I was just on my walk when this formula emerged in my head. And, a lot of, I just recall Poincaré, the great mathematician Poincaré, when he was talking about discovering non-Euclidean geometries, the story that he writes about is like, I was just crossing the street and immediately this equation came into my mind and I knew, it's quite a stereotypical presentation of how a discovery happens in science, and it reflects very much a philosophical tradition of thinking that all of this is completely unconscious. But when we think about discovery more carefully, we think, well, some of this aspect is unconscious, but not all of it, right? You clearly need background. You clearly need to have a problem. Or even if you don't have a problem, you have an understanding of what's interesting around the periphery of the knowledge that you have at the moment, so that you're exploring it. And then once an idea just presents itself in your mind, there's a lot of other work that has to be done, which is purely conscious. You have to evaluate it. So when Poincaré saw the equations, he had to write them down and see whether they made sense mathematically, and then had to kind of assess them as well. So he talks about the delicate sieve, which ultimately will decide which of these proofs, for instance, were legitimate and good, and he talks that that's the aesthetic sensibility that helped him, and that's, according to him, also a conscious process. So it's really interesting, right? We don't have to think that the creative process that invites imagining, all of it has to be conscious or all of it is subconscious, but it's quite a misrepresentation to think that all of discovery is one of those eureka moments, right? It's not like that. It does need assessment pre and after discovery. And so in that sense, all of this is to say there are constraints there before and after the special light bulb comes in.
Well, I'm really happy you brought that up because it really kind of helps me frame the next question. Because in this quite general, sometimes like a bit Mysterian view of imagination, it's also associated with these very emotional descriptions of discovery, moments where imagination played a role. So it seems like it's something that we like about ourselves, that we've been imaginative, creative, and we feel great. So there seems to be a general sense, if contentious, that people seem to be in a way free or happy when they think they've been creative, or someone kind of points out that you have been creative. This is so. And I want to tie this with kind of general consideration about the sort of the aesthetic experience of kind of imagination and whether this plays a role. So kind of your sort of commentary about Poincaré and earlier comments about aesthetic values. So and I know this is a bit contentious in philosophy. What's the role of aesthetic values in science and how they shape how we do science?
Yes, I mean, I can say a lot about this, obviously. I spent half of my career thinking about it. Not that I have a long career, but, I spend a lot of time thinking about it. For me, the motivation always has been I like reading first-hand contributions by scientists and how they recall discovery processes, and, well, it's inevitable that you're going to find aesthetic talk there. So they're talking so much about what affected them, how they came up with ideas, but also how beauty shaped what they discover, but also the fact that the very act of discovery is a beautiful experience, right? So there's so much analogy between appreciating art and appreciating a product of a scientific work. So, whether a theory is found beautiful, whether an experiment is found beautiful, people value the product like they value works of art, basically, describing them in the exact same way, like generating the same emotions, attributing the same kind of values, beautiful, elegant, whatever aesthetic chat you want to include here. But what's really fascinating is just scientists do this among themselves. It's not just communication to public. They make it in private writing. So Einstein talks about, in one of his correspondences, for instance, how when Michelson was trying to measure the relative velocity of the Earth with respect to the ether, he didn't want to just create an experiment that worked. He wanted a beautiful experiment that worked. And Einstein says that Michelson was the artist in the sciences that really cared about delivering that beautiful experiment. And we find this so much in experiments, in theories, in models, in thought experiments, that people do talk about the aesthetic dimension of these products, but also the process that delivers them, and the fact that some scientists are really good at having this aesthetic sense. And that, we recently, there's a really interesting project going on at the moment with the principal investigator is Braden van den Nathan, and he's working on wellness in science, and we're working together at the moment as analyzing some data, but it's basically a really, really large project that studied over 3,500 scientists. And we're thinking about, they've been doing so much work analyzing the data, but so many scientific reportings are about, in the lab, I care to see beauty. I want to see a phenomenon that is beautiful, or I want to create a theoretical model that is beautiful. And it's a really big driver. And the data show that people who cared and experienced those aesthetic emotions in the lab were much happier, or consider that the scientific work is delivering flourishing or something like personal growth, which is quite interesting because we don't usually like to think about these things in philosophy of science, right? Like, let's leave emotional values, we should be scared of these values. And there's good reasons why we have been concerned about these things, of course, right? There's always the fear that if you introduce those things, they might be, operating as a bias, etc., etc. So it's a good kind of debate to be had. But that dimension is really interesting, right? It's correlating with a lot of experiences people having. I'm particularly interested about experimentation, and there, we have so much evidence of just how much emotion and aesthetic experiences are being had every day, not just when you're observing a phenomenon, but also just delivering good design, cooperatively as well, together, people designing something. Obviously, like we have large experiments now, 3, 4, 5,000 people working on something. That collective creativity being also a sense of aesthetic emotion. I should stop talking, but yes, there's a lot of interesting dimensions to the immediate life.
One thing you kind of pointed out, you can comment, and I kind of, would you like to kind of jump in, Adam? I don't want to frame it too much.
No. I mean, I was struck. It's interesting to talk about the Eureka discoveries. I think there's a psychologist who said that talked about the 3 Bs, which is sort of bed, bath, and bus, where these things tend to happen, and going back to Archimedes and so on. But and there's, as you said, I mean, there's debates about, there are cases where, I mean, this happens to me. You think you've had a brilliant idea. Or not brilliant, but you think that'll do, and then you look in your notebook from 2 weeks ago and you think, oh, it's the same thing, and I've said it already, and you see this. So going back to the point about imagination sometimes being external, some of the most famous stories, of course, of these eureka moments are, for instance, Auguste Kekule, so the famous story of the discoverer of the ring structure of benzene, and he tells this story about how he sort of fell asleep in front of the fire, possibly after inhaling some noxious chemicals in the lab, whatever, and saw a snake swallowing its own tail, and had this idea that benzene had this ring structure. And as I understand it, that story, the first public sort of presentation, that was 30-odd years later at a big sort of festival as he was coming to the end of his career. And when you look at structures that are around at the time, and sometimes actual physical models, bits of wood put together with sticks and so on, they have a strikingly similar form, and so it's often very hard to tell to what extent even sincere reports of these aha moments are, as you said, it's sort of little bits of ideas that you've glimpsed somewhere and that are working away somewhere in the background strike you as this aha moment, and you may have had the same aha moment 2 weeks earlier and forgotten about it, and so on. I guess the big question, just picking up on what Milena was saying about aesthetic values, I suppose we've touched upon this already. I guess the traditional view, I suppose, that you might put about creativity and imagination would be to say something like what you said about Poincaré. So that imagination can help us to come up with a new theory, but then here enters reasoning when we test it. And so, Popper would be a classic. I don't care where your ideas come from. If inhaling noxious chemicals in the lab and falling asleep in front of the fire is where you come up with these ideas, go ahead. What we really care about as philosophers is how you test it. But as you were suggesting, Milena, I guess there's a counter thought which says something like, well, but the way in which we decide what we believe about the world, in cases like Einstein, is to think, what explains the world best? And inherent in that, you might think, is, say, what's the simplest explanation or what's the most beautiful explanation? There are 2 competing ideas, I suppose. One, the thought that, imagination only has this productive role in coming up with new ideas, and then something else has got to kick in when we test them. But then on the other hand, this quite powerful thought that really what drives our inferences, what we really think about the world, is our longing for explanation. And what counts as a good explanation is very often something that scores high aesthetically. How you resolve that, I'm not sure. Yeah.
Do you think that kind of also raised, I'm just going to pop one of my podcasts, that kind of, there might be limits to that. Sometimes a physicist looking for a really beautiful idea might actually stop them finding the best theory or kind of the best explanation just because they are too hung up on it being beautiful.
The philosopher Peter Lipton calls this Voltaire's objection. Yeah. So why should we live in a beautiful world? You may find these things beautiful, but why should you think the world cares about what we find beautiful? Why should we live in the best of all possible worlds?
Yeah. Any thoughts, Fiora?
I don't know. No, I agree with Milena, it's true. And also, you gave us the data. It's true that scientists often appeal to these considerations in their everyday work. And that moment, you can also call it the pleasure of understanding. We have it ourselves, right, or with our students, when they finally grasp that, right? They come out of the fight finally
like you're
holding
trying
the
to choke
prize. No, I don't, not that kind of fight. But no, they struggle with complex and difficult ideas, and it's not always easy to articulate or disarticulating the idea so that you see the individual components, and then you understand how they actually relate to each other and what you can develop from these ideas. So anyway, the pleasure of understanding, I certainly can relate to that. I think it's a very natural idea. I'd say I'm not sure that, well, there are two things, I guess, I could say without disagreeing with anything that Milena said before. But one consideration that relates to what Adam was saying is that beauty, or the pursuit of beauty, of simplicity, of elegance, might be one of the drivers, but of course it cannot be the primary aim. So it might be what Elgin, in that collection of papers you edited together with Stephen French, calls a regulatory principle. So basically a principle that you use to guide your investigation, but the actual investigation, the ultimate purpose of that is to I would say, come up with some hypothesis that you can test, and then the real pleasure is having a hypothesis that is confirmed by whatever reality or real-world phenomenon is the one that you want to understand, explain, predict, etc., right? So that is one, so the relation between these aesthetic considerations and what we call the epistemology of science, or the aim, the ultimate aim, which is knowledge. And it's related, but they're not the same thing. And then the second consideration is that sometimes, it's difficult to come up with specific examples right now, but no, I can actually. So there are some scientific discoveries that have negative value, right? So creativity does not always say, it's a value, but it's not always say positive value, neutral value. It can also be negative value. So the atomic bomb, right? So that's the end, right, of a long process of discovery that you might say, well, from purely scientific point of view, look at what we can actually do, harness, right? But from the point of view of what you can do, not as a scientist, right, but as a different kind of human being with that, it's not necessarily a positive discovery. So you might have the joy of understanding how to develop that, but it's not necessarily a positive thing. And you can have it with so many different kinds of discoveries and creations. And what we actually understand now about our possible future on this planet, right? You might have the pleasure of understanding, but actually the doom of realizing what the implications might be, and also the responsibility that comes with that, because then you have to, give policymakers basically some guidelines on what to do, explain to them what the threats, right, might be. So sorry to bring in this dark side, but I think there is clearly a dark side of the story, and it's not just all like Voltaire, right? We do not live in the best possible world. We live in a beautiful world, but it's beauty can.
I think that just teaches us
scary.
that in science you have a lot of values. Sometimes they're competing against each other, right? So my way of thinking about it sometimes is about the beautiful experiment. We have certain criteria that deliver the most beautiful experiment. Sometimes to deliver something like that, you have to cause a lot of harm. We don't do it then, right? When morality and epistemic beauty collide, we have very different feelings about whether something will actually be good. The case of the atomic bomb is a great example, right? It just shows you there's a lot of things going on. We're human beings with a lot of different values. Sometimes beauty will be probably the last thing we care about. Depends on the context.
Yeah.
To acknowledge that these things are there is not to say that they're always good guides, right? You have to assess them.
Yeah.
There's a lot of times when pursuing beautiful theories, it is not leading you to the best outcome, right? Currently in high energy physics is a big discussion whether we should continue the search for supersymmetry. What is the guide to that investigation? It's believing that, the world surely will be used to something beautiful, and it's very much an aesthetic idea of driving, perhaps in the wrong direction, right? Say, what's the answer here? The answer is, well, you have to examine your values at all the times, right? At all times you have to check in on what values are guiding you. And if they're not squaring with other goals, like, well, we also want to understand the world. Sometimes we might have to understand it in a not very beautiful way, but we have to create some other kind of idea, for instance. I don't think these things necessarily undermine the role of beauty in science, right? A lot of the time pursuing beauty is a really positive thing, but not always, and we shouldn't assume so, right? We should just check what kind of values are on the driver's seat and evaluate whether they're really what we want, right? And morality comes in as well. All sorts of things come in when we're thinking about what is shaping pursuit. But to say, I want to go back to the context of discovery, context of justification kind of line, because a lot of the time we think, well, you can allow all sorts of values in coming up with ideas, but then comes the world and comes the data, and whether your data agrees with the theory has nothing to do with the values that drove you, but that is not how science works as well. There's a lot of values that go into how you analyze your data, or what kind of data you looked for. Yeah. Think about gender bias. It's a great example, right? What people see under the microscope, if they kind of have certain kinds of values that believe certain things about, human beings equal men, for instance, they see very different things. There's a really funny paper about the egg and the sperm and the misrepresentations of reproduction under kind of male-driven bias. That's just another funny example to think about how the data itself is so infused with the values that it's hard to think about, the data is so pure and clearly can give us a yes or no answer.
Yeah. So we talk about kind of this sort of, and we happen to do that in the other events as well, kind of making science in a way more human, in the sense kind of raising awareness that science is done by humans. Humans hold up to some values. Those values will clash. Sometimes the same humans have to choose which values to pursue, both in, when they determine their research agenda, but also when they kind of look at the data. And one sort of question that came from the audience in the previous discussion was about kind of, how should we do education better so that, we don't raise this sort of awareness of values at the wrong time, so we don't put the cart before the horse. So I want to think about, pick up your brains about kind of the future of education, both in sciences and humanities, and whether, in a way, flagging more the role of imagination can kind of sway a bit and kind of, do something better or do something different in the way we kind of grow up understanding science, in the way we grow up kind of doing science. So can there be more kind of role for the imagination in our education? We all have children, so we might have kind of, dream a better sort of world for them. So any thoughts? I'm staring at you. So
I spent last weekend building doing a science project with, there's always that thing with children where you have to keep hands off a little bit because otherwise if they win the prize, then you feel like it's really your prize rather than theirs. So I think broadly construed, there's what the philosopher Thomas Kuhn talked about as being a tension here, right? So that between, on the one hand, valuing creativity, valuing the ability to come up with alternatives, alternative explanations, alternative approaches, and so on. And one of the points that Kuhn emphasises, which is that science is a fairly authoritarian discipline. I mean, if you sit there in science class and the teacher is saying to you, well, these are Newton's laws, and you sit there being a philosopher and questioning them constantly, you never get any work done, is the thought. So there's a sort of, I take it that one of the questions for us about imagination is the extent to which we want to be constrained, and it seems like either extremes are bad, right? That if you don't look into alternatives, then you'll always remain stuck. But on the other hand, if you let too many flowers bloom, you end up with as many views in the literature as there are people, it's hard to see how you make progress that way either. So I think there's a real, there's an essential tension that's between those two, and I don't have obvious ways of trying to resolve that, I'm afraid.
Any other thoughts?
I mean, I think what I found really frustrating in just learning about science was the lack of the human in them, right? So you learn a lot of facts and you can learn how to do things in the lab, but you don't learn what made this possible and why did someone want to think about this in the first place. But I found that also studying history of art and the realization, I mean, that's what drove me to history and philosophy of science, this realization that when you look at the history of art and you look at the history of science, the same thing goes on there, right? People are thinking outside the box, but within very well understood constraints. They know their, subject really well, but then they have that ability to jump a little bit or identify something that could be tweaked in a really productive and revolutionary way. Everyone that ever produced anything original and, highly impactful had that ability. And probably what I would say is just, I would love it if science students did more history of science, more art, that they can see that connection. So we don't have that, terrible, counterproductive distinction that was STEM subjects are completely separate from the humanities and nothing between them. And it's really counterproductive. It's creating a lot of, unhelpful narratives about both disciplines. So having a little bit of both in your education, even at university, is really helpful.
Yeah.
Right?
For once, we won't announce the death of the humanities every other 5 years, and then we might not kind of have to say we need to invest even more money in STEM or no, even more money in humanities. So you get all these sort of polarizing big debates about that.
And it's going back to just conversations with scientists, right? I really like talking to scientists. So a lot of the times when we talk about why they take philosophy, for instance. I mean, I mostly work with scientists in the making, but they take courses. I mean, they are really interested to understand all of these questions about the imagination, aesthetic experiences. They come in thinking that, there's all this awe and wonder in science, but also they want to understand how that happens historically. Oops. Don't leave me. And so there is probably the connection between the two is really important, to learn it, to appreciate it, and see that people do these, use those tools. If you think the imagination is a tool, probably a really bad way to phrase that. But they use that in both fields, and it helps to understand the relationship between
them. Yeah. Any thoughts, Fiora?
I tend to agree with everything that has been said. So I'm just thinking, maybe one thing that I would emphasize, so it's true that it's important especially for the students. So one thing that I know from a qualitative study done by a colleague, Mike Stewart, on how to teach to imagine properly, right? And what happens in a lab, if you ask scientists whether imagination is relevant to their work, what usually happens is that the young, new recruits, right, they are very, very skeptical and very careful as soon as you mention the word imagination, because of this intuitive notion, right? The fancy of the imagination, right? The irrationality of the imagination. It has nothing to do with reasoning and facts. So, of course, there is this intuitive notion that is really not appropriate in that context. But the senior members of the lab are much more aware of the role that a certain kind of imagination, of course a constrained one, right, plays in their practice, and they are much more confident, and they say, oh yes, of course, and it's all about creativity. And to be honest, it's an industry as well, right? I mean, nowadays, if you're not a creative scientist, if you don't publish that certain amount of papers every year that all need to be slightly more original than the previous one, you can forget about tenure and having that research grant. So there is an overinflation, I think, of this notion. Okay. So we need the time to develop the relevant, meaningful, significant type of imaginative projects. Yeah. And probably what is stifling a lot of scientific research right now, why don't we have the kind of scientific discoveries we had at the beginning of the past century with the incredible kinds of discoveries and theoretical developments we had at that time. Why don't we have them now? Probably because there is this kind of competition at who is the most original, but what you can do in the short term is always that small additional increment, right? It's not coming up with anything massively new. So you have to probably identify the right, when we talk about teaching students how to be more creative, more imaginative, we need to understand what that actually means, and also we may have to rethink about what kind of creativity we want, what kind of imagination we want, and for what purposes, right? So sorry, just to add again, and
that's a really nice, kind of nice way, kind of wrapping discussion. But because this is the last event in the series, I want to kind of just throw out there one last general question, and it's just pros and cons. We don't need to like prophesize and like about kind of boundaries in the future between kind of disciplines. How much do we need them? It's like, so there are pros and cons, you know. Any thoughts? Kind of imagine the ideal world, or kind of be realistic about what's kind of possible about these boundaries.
Between which?
Between disciplines. So you can think science and philosophy, like physics and philosophy. Take your favorite sort of disciplines and think.
Can I keep my job? Given that that's how a lot of these, being slightly cynical about it, these boundaries are actually negotiated. I mean, you know, the boundary between science and philosophy has been, you know, at least on one reading, a desperate attempt by philosophers to justify their paychecks for 150 years or so since the ascendance of science in the Victorian age. I do think that, you know, I've taught philosophy, history, philosophy, science to medics, trainee medics, to people who are going on to finish a science degree and so on. And I think, and that was my own trajectory. I was doing maths and physics, and then had a bit of a personal crisis at where things were going, and dropped out, and you know, worked in a pub for 6 months or so before doing philosophy. And you know, for me, it opened up the sorts of questions that Milena's talking to. I think, you know, looking at the past. The past is often, of course, a way in which your imagination gets opened up to possibilities that it's you know, seeing that there are very, very clever people who've thought about the world in completely different ways to the way we do today is always an important lesson, I think. Even if we stick with our way, we might realise what we're aiming for a bit more clearly, I think.
Thank you. Fiora?
Yeah. Okay, so these distinctions are usually, I would say they are often cultural and historically located. And so in the UK, we often talk about STEM and the humanities, right? In other places, we talk about STEAM, right, which has art in it, right? So if you're Italian like I am, so art means architecture, design, etc. Right? You study that kind of things in a what is called a polytechnical school. So basically in a technical engineering kind of university. There are so many different acronyms. I mean, you can add all the letters of the alphabet, you come up with right? And I think it depends on your tradition. So when Popper was thinking about what distinguishes science from pseudoscience, you hear science in English and you think the natural sciences. Popper was thinking about the Wissenschaften, so that's all. So the social sciences, the natural sciences, the humanities, and philosophy was not a humanity, it was philosophy and mathematics, right? So it's a very different kind of, a different kind of garden, let's call it. And he was trying to find the unifying methodology for all of these different sciences, right? So I guess I'm with Popper, I would say, but I do appreciate that. Of course, there are methodological differences when you go, so applied science is one thing. So when we think about STEM, we have mathematics. The M in STEM, mathematics has nothing to do with facts. it's not applied. Mathematics is really about, if they exist, abstract objects, probably they don't exist, so it's really about nothing. And yet you need it, it's true, and yet you need it as an instrument to be able to look at the world and divide it into these relevant, right, elements and see what the quantitative relations are, etc. So it's a way of describing the world, if you like, by a mathematician with his pencil at his desk, not even with a computer. I mean, he's not really thinking about anything concrete, empirical. So it's nothing applied. And yet it goes with engineering, right? Science. I don't know why. But you see, so you can articulate these ideas in so many different ways, depending on.
I think these disciplinary boundaries have something that they're doing, right? They do generate sense of belonging and identity that is quite important, right? You can't, if we are all blurred, it would be very difficult. People need to identify as something, and groups need to have communal identity as well. So that's why this works. This is why it's important that you have, we are philosophers. We're doing something together. It works. It's, pragmatically it works. But it's really important that this myth about the division is, slowly goes away, and we understand that, fields have a lot of overlap. A lot of philosophers overlap with scientists. A lot of philosophers do exactly the same job as scientists. If you're thinking about theoretical physicists and philosophers of physics, they do exactly the same things, often with the exact same tools. And to understand that the methodologies in science are so diverse and there's so many methods, the proper question, if we were to answer it today, would be, there is no method, there's methods, right? There's a lot of things people do, whether they're in the lab, whether they're in the field, whether they're with a pencil, and whether they have an eraser or not. We apparently don't have an eraser. Philosophers just need a pen. Whether they're mathematicians, people do different things in their subjects. So we need to understand those, boundaries are blurry between subjects. Understanding that is really important, and that's not to undermine that we can't have these identities, but we also need to have the understanding that you have these boundaries that are not very sharp, and it's really, really important not to have the undermining of, philosophers are useless. Why should we have philosophers? Everyone is doing something in this picture that is quite a collective activity at the end of the day. So yes, I'm not against having these boundaries, but I also really think we have to think about what's shared. Thank you
so much. Now that Milena justified our job, so we're going to keep them. I want to invite the audience with questions on topics we kind of try to raise, but also kind of additional sort of question, thinking about science, humanities, or the imagination in general. Okay.
Thank you. I haven't used the microphone in a while. Just trying to bring it back to kind of the first question. Sorry. With some sorts of sciences, like social sciences, including economics, it's sometimes, you could argue that it's more important to imagine how something would look, and it's more about the imagination and the idea behind it, rather than what you can rationally deduce. Would you agree?
I think most economists, I'll just jump on this, kind of disagree with their mathematical modeling that's what. So it's not kind of there is this sort of idea in many of the social sciences about kind of what Milena has been kind of testing the idea. So it's true what you point out, that kind of, evaluating counterfactual, how things might be different, and kind of checking all of this. So there seems to be this sort of detachment from reality and from the actual world. And again, going back to economics, you might think they have such abstract ideal models. They definitely don't fit the messy world we seem to be living in. And so many of the models seem to make the very wrong predictions about the real world. So in a way, it feels that kind of a bit way. But I think there will be resistance from the part of the economists, the scientists, kind of saying that there is not this sort of rational calculation that goes beyond this. And maybe this kind of goes back to this sort of idea. They also work within certain constraints. Sometimes it might not seem so, but quite often they'll be able to point exactly why they made certain assumptions in there. Right? Any other thoughts about the social scientists?
Yeah, but please.
Well, I'm not sure if this is, so when you were asking if it matters, I mean, I guess one thought, of course, is that unlike rocks and atoms, we can hear what people say about us and we behave differently. So the philosophy in hacking is use this term looping kind. So in other words, if we're talked about in a certain way, we can change the way we behave. So, economist models, the country as a household, be an example of a sort of a model that then, right or wrong, whatever its drawbacks, then of course can change the way people vote, it can change the way people behave. If people are told they're inherently making rational, selfish judgments, they may, make different judgments as a result. So I mean, one sense in which it might not matter so much, there might be another dimension to those views other than whether they map the world right or not, is that they may end up mapping the world better because we change the way that we behave when we hear them. So, and that's one respect in which people have often drawn a distinction between social sciences and other domains.
Any other sort of thoughts, questions? Yeah. One in the back and one in the front. So whoever gets the mic first. Tom, I think you lost.
I'm interested in the concept of agnotology, which is the study of ignorance rather than the study of knowledge. So the conversation today has been all about how can knowledge be produced through imagination, but is it perhaps possible also that ignorance could be produced through imagination as well?
Thoughts?
Sure. Yes. Yes, of course. So the imagination needs to be rein in, right? So we shouldn't be too enthusiastic when we use our imagination in science. I'd say we should always use it in a, how can I say, with responsibility. And usually what scientists do, they learn, so you were talking about scientists as being very authoritative, you were just saying a moment ago, right? And I had a moment of,
Not my
I don't
words,
know. No, I think, so you need competence, which is a word that we don't use a lot, but it's a word that we should use more. So it's about competence and knowing how to do things, right? By learning as members of communities that have their own practices, but the practices are under scrutiny all the time, right? And that's what scientists do, I guess, their best. So they may not think about the role that imagination plays in their practice, but they can see very well when they are moving in a direction that is not acceptable, fruitful, a potential, right? So they tend to close certain potential venues and tell the students, when we're talking about students or their colleagues, that's not the way to go. It's not, and you also see it. I mean, there are so many dead ends in any scientific endeavor, right? So definitely we should be very careful in the way we use our imagination, and I think it's about competence, right? That's the word that I would use.
Just to say, I mean, I guess one context, I'm not sure if this is the context you're thinking of, agnotology is things like research funded by tobacco companies into whether smoking causes cancer, for instance, and often the justification given is appeals to what looks like a very noble epistemic aim, which is we just want to be sure, so we're just funding, we're just, and similarly with climate change, the jury's out, we want to be, and of course there's an imaginative move that's often used by philosophers that might be inappropriate in the sciences, which is skepticism, basically. So if you can imagine an alternative interpretation of results and so on, then you haven't achieved certainty. So there's it's one example of this way in which the imagination, is should be better constrained sometimes in the sciences, simply because one person can dissent with a possible alternative explanation doesn't,
Well, can I add something to this as well? I completely agree. Like, science is very special because we have structures in place to ensure that there's no just any belief goes, right? There is a lot of criticism in science to make sure that, we don't remain flat earthers, for instance. But what is happening with people who are defending such ideas, such as the earth is flat, they are limiting their imagination. They are just completely saying, well, I'm not going to imagine anything else. If you have a scientist telling you the Earth is flat, they will immediately invite you to run a lot of thought experiments to tell you, and also tell you to look outside. But there will be a lot of other things you're invited to do to tell you, well, no, the Earth is not flat. But in the kind of field where mistaken beliefs kind of persevere is because people are not invited to criticize each other's beliefs and things are not put into question. There are no thought experiments entertained against the idea. So it's a lot of things are lacking in that structure that are present in science.
And I was thinking when you mentioned diagnotology, I was thinking there are many things that are covered there, because you can want to talk about misinformation and how being driven just by imagination to come up with ideas might create out there all these sort of information that are kind of misguided. But it can be kind of ignorance is slightly different, isn't it? It's like when you don't care and you're not looking for it. And I think it's like imagination is still a step towards kind of the right, at least you're trying to get your head around something. And then there are different, depending on your kind of domain or the area you're studying, there might be constraints. So the exercise of imagination will be a bit constrained. You can imagine certain things, but not really others. So I definitely see the functions of the imagination, as multiple as they are, kind of a bit step forward from ignorance itself, because ignorance is just, I don't care, I don't want to know. So there is no sort of attempt to interact at all with the world and so on. But it's kind of interesting how imagination relates to these other concepts, kind of misinformation or kind of falsity or kind of lies or things like that. And I think there's a lot of space to explore there about what should we think about when we promote the use of the imagination, what sort of extra constraints, depending on the domain, we need to have in place to make sure, I was thinking really recently, just to connect it with the first sort of session, all these hallucinations that GPT systems have, they kind of create all these sort of, you ask them a question about a famous person talking at this philosophy conference, and ChatGPT is going to give you a summary of what this famous scientist talked at the philosophy conference that never happened. And, and then, so the system is able to produce, imaginatively, all these kind of very elaborate sort of, and, that's not ignorance, it's not like the system, but the system is producing misinformation. So there are certain uses of sort of imagination understood in certain ways that I think kind of are also helpful to think about. There was a question from Tom in front, and then...
Thank you very much. I'll try and keep this succinct. So many ideas buzzing around after that conversation. I think it follows a little bit from the previous question. So I kind of want to be a bit more polarizing, maybe a bit more polemical. Going back to the way Maria framed this conversation right at the beginning, and given that you're all philosophers of science, you said our current situation, our current culture is pervaded by science, which I think is probably true. And so we have a situation in which, at least insofar as we are in a university or some other educational setting, the default mode is we want to get some knowledge. So the question of the lecture is knowledge through imagination. So the assumption is, can we think of ways in which imagination can help us get some knowledge? And I didn't need a lot of convincing of that. I mean, you gave some beautiful examples, and I was really pleased in a sense that there are all these ways in which imagination can help us get some knowledge. But I also wonder whether, if the pervasive kind of situation is that we want to get some knowledge, then there's a danger that we train ourselves into using the imagination in a very particular way. And I wonder if it kind of distorts our general thinking about what the imagination is capable of and what the variety of things that we might want to end up with from an education in general and from kind of culture in general, I suppose. So, sorry if this question's going on for a while, but the sort of thing I had in mind was, so you nicely brought out a tension in our kind of imaginative practices, or several tensions in our imaginative practices, as they work in science. So one of them that I wrote down was, sometimes imagination is productive, it gives us images or it gives us ideas, but in other ways in science it's sometimes used to be simplifying or constraining. And I kind of wonder, in other cultural practices, we have imagination that can be extremely simplifying. So I think paintings by Rothko, Rauschenberg, sometimes completely just a simple colour or a square, or paintings that go the other way, that are just simple production of complexity, Bruegel or Bosch or something like that, right? And you sit and watch a painting, look at a painting, and you don't necessarily want knowledge out of it, right? So you get those two possibilities of imagination, and you have the tension, and you maybe push one to the extreme, and part of cultural practice is to just be happy to sit with something very simple or something extremely complex and not put it in the service of knowledge. So I think you can see where my question is going. And I suppose in your answer to the previous question, you said ignorance, maybe it's like the desire for knowledge gone wrong, or maybe it's a failure of the desire for knowledge. But maybe it's neither of those, right? Maybe it's just ignorance is just nothing to do with wanting knowledge and doing something completely different.
Yeah, I mean, so perhaps I should say, so I mean, what I've been interested in, I guess, is from the thought that if you think that science is about knowledge, then about gaining knowledge, and that's your view, and you could have other aims. I mean, we say things like, science aimed at understanding, and it's not at all clear that understanding is the same thing, or we just want to build things that work, or try to, make the world a sort of more comfortable place for us to live in, and those are aims. So it's not obvious that that's the only aim of science. But I guess for me, what's been interesting is even if you think that's the aim, then there's some, in my view, surprising commonalities between, say, the process of modelling in the sciences that I started with, and something like children playing games and pretending, and that's so. Now, but I don't think so. When I said that these things are simplified, I didn't mean that as a negative, right? So sometimes, coming up with a simplified, idealised view, sometimes it's just the best we can do. But sometimes it gives you more understanding than a horribly detailed, like Borges's map that's as big and complicated as the terrain itself. So sometimes understanding pulls in a different direction to knowledge. For instance, you might think you get more understanding from a simplified model than you would with all the gory detail that may still constitute knowledge about it. So the other thing I would say is I wouldn't at all want to say that whatever role I might see for imagination as helping us to gain knowledge in the sciences would apply in other areas. I'm not even sure it applies in philosophy. I mean, I wouldn't want to have a view that tied philosophy very close to the sciences, actually. There may be all sorts of other aims in terms of understanding and humanistic notion of understanding that we're getting in philosophy and history and so on that's quite distinct. And imagination may have roles there, it may be a very different role. So I wouldn't want it to suggest, I wouldn't even want to say that whenever we're trying to gain knowledge, if that's the aim, that imagination has to play this role. I mean, maybe giving a historical account doesn't involve the sorts of difficulties that giving producing a scientific model does. They're maybe just different activities.
And I would say also that sitting in front of the painting, I mean, most of the time when you're engaging with art, you're doing exactly the same thing you're doing when you're running a thought experiment, right? You're engaging the imagination with the aim to gain something out of it. We very rarely just sit in a gallery and just sit there, right, and absorb. We are engaging in a way that we're learning something. We want to learn, why is this square there, right? What did the artist want to do with this square? Why am I looking at this? With a novel, it's even more obvious, right? You're just going to imagine all sorts of, possible scenarios in which, how would I feel if I was subjected to this and that, for instance, or whatever. So in art, you're engaging in a lot of those learning activities as well, right? So again, the boundaries between the methods and goals are quite blurry. Yeah, that I just wanted to add that, right, that it's very rare that we don't have a goal, and we have that goal with art when we engage with art as well. And artists have that goal as well, right, to evoke certain responses to guide you to do certain things rather than something else.
Yeah, I was thinking, so when we think about the function of the imagination, so finishing where I started, right, so with the idea that we evolved this ability, not that other animals don't have it, right, so there are some studies, but not in the same way that we have it. And it seems that what the imagination has been selected for is something like enabling that flexibility of thought that is manifested in the flexibility of behavior that humans need to adapt to different environments. If we were just in our own environmental niche, right, we would probably not need to think about alternative possibilities, to plan for the future, to solve problems. We would just have this, and this is what a neuroscientist told me actually when trying to imagine, right? So putting ourselves in the perspective of most animals, what kind of experience of the world are they having? And it's probably just this flow of perception, continuous flow of perception. And it guides them, of course, in their behavior in the environment, but with no flexibility. And that's the reason why so many animal species are getting extinct, apart from our own role in that, right? But if you change the environment, they're not fit to that different environment anymore, and they cannot adapt, right? So you may think imagination is not only useful because we can learn, right? It's useful because we can contemplate these alternative ways in which we could exist, let's say, or we could survive in these different solving problems. And this flexibility needs to be exercised, right? So when children play games of make-believe, with the typical, stereotypical ones, there is this hypothesis that what they're actually learning is a sort of skills that as adults, the kind of Stone Age people that we still are in our brains, is the sort of skills that they will need as adults in their social, biological role. But of course, they also play other games and they are flexible. It's not that girls only play with dolls and boys only with, machines and changing the environment, right? That's very stereotypical. The flexibility is in both, right, kinds of little people. And they can do much more, and they need to be free to play as many different games as they can, because they can develop all of those skills that they might need in different circumstances, in different situations. So learning, I think, is really and adaptability is really the core. And then we can have knowledge, and then we can have insight into other people's perspective, making sense of other people's behavior, decision-making, understanding what the other person will do next, especially if you're in a competition game. It's important that you use your imagination, right, to predict their next move. So it can be used in many different ways, and that's the beauty of it, I would say, perhaps.
And as the person who went for that title and put it on the slide, I feel I should comment that there were two intentions sort of behind it. But one intention that wasn't there was a reductive one. So kind of saying that there is only one function to imagination. And actually it was a bit challenging, this very, again, philosophers really traditionally fancy this very factive notion of knowledge. Knowledge is just accumulation of facts. And you see that in the education we give, like science. In science, it's like, and you hear it, we heard it like from panelists last week, kind of students come to university and expect science to be about this accumulation of facts. So kind of by putting those together, so one intention was, how can maybe broaden or kind of think critically about our conception of knowledge, especially in the sciences, but also more broadly, if we focus, rather than on facts, on data, we focus on imagination and its function for kind of creating sort of knowledge. So there was that direction. Let's learn from imagination about what knowledge means for us, and maybe we are a bit too short-sighted in thinking that knowledge is about facts. And the second intention was, let's think about imagination. I mean, it's a bit surprising. I mean, we have all these great philosophers who have thought about imagination, but if we put it in a historical scale, we have philosophers being really not making up their minds what they think about imagination. You take like just three. You take Aristotle, you take Hume, you take Kant. They kind of seem it's great, but kind of unconscious. Reason is more important. We talk about reason, we analyze reason. And we get like this new and for me quite exciting work about imagination, not only from philosophers' side. There are like plenty of philosophers out there wanting to say like there is more to discover about imagination itself. And maybe one of the functions of imagination that hasn't been explored enough is just one related to knowledge, but definitely not the only one. So kind of the intention is kind of basically kind of make these concepts explode and kind of think about knowledge and think about imagination, which I think is kind of closer to your heart than kind of just the reductivist picture. Any other questions? Yeah. He's also in the back.
Thank you for your talk. I just wanted to ask about your feelings around imagination as in the role of understanding scientific knowledge, either by the scientific community as well as the wider public. So having read bits of literature about science and things like quantum mechanics and debates within the scientific community around how to approach those theories, some scientists say just shut up and calculate, and they don't say, well, don't ignore the calculable things. It works, the theory works, but are we facing, I don't know if you feel we're facing a challenge to human imagination in its inability to understand or comprehend theories that are beyond classical science, and there's an inadequacy in our language to really kind of communicate what is understood.
Yeah, it reminded me of my days of trying to do the philosophy of quantum mechanics and having done this, and I was trained in I guess, conceptual analysis philosophy. So the sort of aim there was to think about your intuitions. And when you're presented with something like quantum mechanics and you're asked, well, intuitively, what's happening here? You think, well, I don't know. I mean, because it's so far from my sense of how ordinary, medium-sized dry goods, as people say, tables and chairs behave, that there is a sense in which you feel as if if imagining is about visualizing or something based on your ordinary experience that it gives out at that point. And of course, it's familiar from, there's this famous distinction that Pierre Duhem, the physicist and philosopher, makes between the sort of English and French. So the French are sort of happy with the formal systems of elegance and calculation, but the English have got this post-industrial revolution emphasis on machines, so they've got to build something with bits of wood and metal and so on before they understand something. So there's, I'm probably on that side of things, probably why I didn't do very well with quantum mechanics. But I think, yeah, I mean, I guess one thing I would want to say is I wouldn't want to link understanding just to being visualizable. So very often what we mean by understanding, I think, is something like an ability to do various things, to apply the theory in a new area, to say what would happen if things had been different and so on, and people can get that ability in all sorts of different ways, and there's some people who seem to have got that ability in quantum mechanics that don't have. So, but yeah, I think there are. I mean, another way that comes, of course, is just sheer complexity. So something like climate modelling. Just, of course, that's where we resort to machines very often because it seems in a different way outstrips our capacity for imagination.
I definitely agree that some areas are less visualizable, and that's one theory classically that we cite that, well, we can't really visualize a superposition of particles. It's really difficult. But we can understand how it works in order to solve an equation. And that probably teaches us that the understanding has many different ways in which it works, and sometimes we understand without visualizing. My favorite example of it's kind of a funny revolution that happened in early physics is think about Newtonian mechanics and philosophers that connected to that physics at the time, like Kant would tell you, you cannot possibly imagine the world not in 3 dimensions on a Euclidean plane. That is not possible for your brain to do. That's not math you can compile. It's not possible to have that experience, to imagine having that experience. Well, what did mathematicians like Lobachevsky and Riemann did? They imagined those spaces, and they imagined negating the fifth axiom of Euclidean geometry, but could they visualize being in a hyperbolic space where you can draw infinite lines to a line that you have in mind? I don't think we will think they visualized it, right? But they were able to imagine how to create that mathematical system, and one of those mathematical systems ends up in your physics later on. Another thing where purely mathematical system one day finds its way into the physics. So understanding and imagination and visualization, they're not always going together, right? But you can understand in other ways without having this image in your mind of what it's like to walk around in that hyperbolic space, for instance. So Kant was wrong.
Should I add something? I don't know.
If you have anything to add, it's like...
I think what Feynman had in mind when he said, stop trying to understand, just calculate, is that you shouldn't try to understand it as Einstein wanted to understand it, which is to have a sort of quasi-observational experience, and also to have the notion of causality as local, right? Which is the one that we have in ordinary physical interaction with the world. So if I kick this table now, something will happen, right? And it's because there is an impact. How is it possible the two particles that have been prepared, right, in an entangled system at the origin, but now are too far apart to share any sort of information, and yet you change through measurement the property of one and the property of the other? That's what the equation tells you, right? Will change. That's what Einstein couldn't accept. He couldn't understand how is that possible. There must be some causal link of the kind of causality that we call, that is the one that we can experience. So understanding as experiencing in the imagination, that's also what I think you were referring to when thinking about imagination as visualization, right? But obviously that's not the only, so when we talk about understanding, I think that's the notion that Feynman, Einstein, and the physics students usually have. But then we have this other notion. Sometimes we use the word conceiving, right, to describe that. And it's more of an abstract, conceptual sort of imagination, I would say.
Yeah, but I just wanted to add, maybe this is a bit orthogonal to your question, but there's this sort of idea, especially if you look at the science communication and you look at popular science writing, you will see lots of metaphors, lots of imagery being used to present really complex ideas. And that's why you get so many people very hyped into quantum theory and so on, because of the visualization, not because of the math. God forbid. I mean, it's not because they want to kind of do all those complicated calculations. And I think these images, sometimes they do serve a role, so like we discussed last time, they do serve a role in kind of disseminating these ideas, kind of saying, there is a theory out there, it's very outlandish, this is an image you can put on it, it's not quite right, it's not capturing all the mathematics, but it can also be a bit distortive. It can lead the wider audience to kind of say, oh, it's as simple as that, as this image. I'm just going to imagine this donut, and kind of that's the essence of the theory. And then people tend to forget, but physics is a lot of mathematics, and a lot of very complex mathematics. So I think imagination can play an important function in communicating some very complex ideas, and giving a feeling, if not a real understanding. But there is a sort of, the other side of the coin is that sometimes it kind of distorts maybe the more complex, more kind of conceptual sort of exercise that has to go into grasping properly some of the kind of ideas that we get about climate or about typically physics. Actually, biology is so complicated and messy. We always give examples from physics. But whenever I'm talking to biology, they say, why? Biology is so messy. Each individual is unique, so we should come up with some. I'll kind of do my best for the next questions to come with examples from biology. Yeah.
Yes. the thing is, one of the things that strikes me is that I sort of felt in the earlier discussion that there was a notion that the scientific imagination should be somehow constrained. But if you think about Heisenberg and the uncertainty principle, I mean, that's a wild idea that destroys our whole notion that the world is a certain place. You think about Einstein, who destroyed the notion of simultaneity and the immutability of space and time. I mean, these are giant leaps of imagination. I mean, I think we should encourage scientists, as a scientist, be absolutely as unconstrained as possible. The other point I would make is that scientists don't work in a vacuum. They work in a community. And their acceptance depends on the reciprocal imaginations of the community. As a postdoc, I sat in a seminar when Peter Mansfield, who later won the Nobel Prize for magnetic resonance imaging, was talking. He was talking about what he called then NMR diffraction. And the wiseacres were saying, oh, it'll never work. You cannot possibly get any kind of useful resolution. Of course, as a brilliant young postdoc, I agreed with them. He later said that, in fact, he had a great deal of trouble getting money for his research because nobody thought it would work. So you can't talk about the scientific imagination without recognizing that there's the imagination of the community that counts as well. But there's also a wider thing. You mentioned the amazing burgeoning, blossoming of science at the beginning of the 20th century. But at the same time Einstein was writing special relativity, Picasso was starting the first abstract painting. Freud was active in Vienna. It wasn't just science that was doing something. There was a whole community. There was something going on in society and culture that what it did and how it did it, I have no idea. But again, science is work in communities. And even the bigger community has a role to play in the scientific imagination.
Yeah, I mean, I think this sort of dimension, sort of collective dimension, as philosophers, again, quite traditionally, you can disagree with me, but that's my own take. We like the sort of, let's root everything in the individual, is about individual knowledge, is about kind of individual imagination. So we have this, and I think, in a way, flagging as often as possible the sort of kind of social collective dimension, and that, there is this element of being shared. And it's not just an afterthought, it's kind of an important sort of insight. Any thoughts?
Yeah, I mean, I would think the social dimension is extremely important. So that's why that's why I wanted to talk about imaginative activity. And the main parallel that I've been interested in myself is with games. And games are social activities. And as I said earlier, you can get things right or wrong in games. If you're playing with dolls and you pick the doll up and say, right, 5, 4, 3, 2, 1, then you've either changed the game or you've done something wrong, right? So there are rules for what you're supposed to do, what you're supposed to imagine in the games, and I think that's perhaps something I'd want to emphasise in the scientific case as well. So if in modelling the world we're asked to see it in a certain way, so we're said, imagine the planets are perfect spheres. Imagine that you only have to think about the attraction between the sun and the earth, and you can forget the rest. Again, that's a context where, as you say, it's a social activity, and if one of your students says, then the force is inversely proportional to the cube of the distance between them, you say, no, you've got it wrong. So it's a context in which the imagination's involved, but it's constrained just in the sense that there are norms for what you should and shouldn't imagine given the particular model you're using, the particular context. That might be quite different from the creative role of the imagination that you mentioned with the cases like Einstein, where you feel as if there's a radical change in our view of the world, and it may be that if there is constraint, it's something different.
What do you think, Milena? Are there constraints?
Yes, I mean, I think when we think about these radical transformations, they do seem very radical until you learn context And then you think, okay, I can actually make sense why Einstein and not me came up with special and general relativity, right? Context matters. He was at a particular time when there is a particular polymerization, but he also was already very familiar with non-Euclidean ways of thinking, and he's already very familiar with Poincaré's work and Lorentz contraction and all of those things that are introduced. The further, he just needed to take that extra step and, reconceptualize the way we think about something that, it's not like people couldn't explain motion with the other tools that they had. He just simply introduces another way to organize ideas. But it didn't came out of nowhere, right? I mean, it was exactly the point that you made, that it's a social activity, and already at the time there was enough ingredients for him to then be able to think how to reconceptualize the particular understanding at the time. But this is what we mean by the constraints, right? The constraints are, well, he knew the physics of the time, he knew the problems of the time. You have to synchronize clocks. There's this really fast engine going in the trains, like the fastest thing. We want to know how to synchronize the clocks. This is what he's thinking about. So it comes out of a particular problematization at this particular time, and through the knowledge of the constraints of the rules that you have, the laws that you have at the moment, right? So in that sense, of course, we're not thinking of Einstein came out with these revolutionary ideas out of nowhere. They are pre-existing ideas. But the collective imagination is a really interesting thing, and I wish we knew more about it, right? Because it's very interesting. We can go back to 100 years ago and think, oh, these great minds that changed everything in art and in science. But at the moment, it's not like this. Many people together are changing something. Often you don't know how to credit people, right? Accreditation is such a big problem in science today. There's collections of people that will never meet each other that discover something. They've never spoken to each other. How do you understand the collective creation there? And then who deserves credit as a second step? What exactly is everyone's involvement in a process like this, in a creative discovery, for instance? And not to mention, of course, that now you also automate creative processes, which is even more complicated. Right now you can discover thanks to the algorithm that helped you organize a particular, arrangement of an experiment, for instance, right? I love this case of a recent scientist that basically was trying to entangle in 3 dimensions and 4 dimensions, and he trained an algorithm to do that. And it's really fascinating how, the only reason why this was possible in the lab is because the algorithm was able to deliver the arrangement. And so you get to wonder now, okay, how is that going to change the way we think about imagination in this particular context where, machine kind of substitutes so much of the reasoning that usually goes on in a scientific discovery. So it's really fascinating. But yeah, coupling people together and coupled with a machine, this is really interesting how, as a process, how it works.
Yeah. And I like to think, there's something I like to tell my students, because I strongly believe that kind of fits. I mean, you cannot really change the tradition if you don't understand it. So it's so that's what I understand by constraints. And like, as Milena said, so the sort of background sort of knowledge. So otherwise we send like science students the wrong message. They don't need to learn the science to be creative. So I think, and that's kind of my question about, when should we raise this awareness about the values in science, about kind of creativity and so on? Should we just, I think we can do it maybe kind of in an embedded way from very early on, but I think the meta-reflection about the role of creativity needs to come against some sort of a background. They need to know how to do some of the things before they can, the creativity or kind of imagination understood as this sort of complex patching of ideas is giving something new. And I think, as Milena was suggesting, this reconstruction of historical episodes of almost, I feel like, magical transformations of the way we see the world. Once you look closely at them, you can see how it's kind of built out of this background knowledge. But the other element was kind of linked to something that Fiora mentioned about it is an industry, so kind of science as much as kind of and any other sort of producing knowledge. So therefore, there are going to be limits, which things get funded, which things are seen as being useful for society and things like that. And maybe there, in terms of that policy, we can be a bit more open-minded. Maybe maybe we're a bit too conservative there in what we fund, and traditionally maybe we have been so. So, yeah.
It's kind of, sorry.
No, go ahead.
It's interesting that big projects like NASA and CERN use so much of the funding to generate excitement in the public and kind of trigger the imagination of what discovery in science looks like. The reason is this costs so much money. You know, you have to justify it, and they do a really good job of trying to fascinate people, to be interested. I mean, I remember last year with the gorgeous images that everyone had on their screens, you know, on their computers. Why is this happening, right? They want to get you to think about scientific, you know, discoveries as these really exciting moments, and you're part of it. It's part of history. It's an effective tool, right? Just triggering public imagination and understanding that there is a lot of emotions involved in science as well.
Mm-hmm. Do you want to comment?
I
put you on the spot all the time, but if you like.
No, I think you've said, I mean, the kind of imagination I usually talk about in my work is collective imagination. It's not, I've never talked about the individual imagination, although I think that a collective one emerges from the collective minds of the individuals. So of course I'm also interested in the cognitive science of the imagination. But I think that we do have a lot of, how can I call them? So actually Adam and I developed a view of models that is different in some ways, but similar in others, because we both appeal to a particular notion of imagination as make-believe, which has to do with the games, right? And in games, usually we use props. And I think that scientists often use props, not dolls or toy cars, but they do use mathematical symbols on paper or on a computer screen, linguistic symbols, all the ways in which we can communicate information. They need a perceptible vehicle, right, that we can interpret in the same way or a very similar way. So the constraints come from the let's call it the infrastructure, the physical infrastructure that we need to be able to share information. But then also ways of doing things, right? Purposes and goals, and then experts' opinions, domain-specific knowledge, and then the very architectural constraints. So when we imagine alternative possibilities, we usually think about alternatives that are relevant, that mirror in some ways the things that we already know about reality, for instance. Inferential reasoning is fundamental as well as a constraint. So there's a lot to be said there to articulate that notion. But it is being said. I mean, we are working on it. So it's not that we are limiting everything to the individual scientist, right? I guess that's what we should say.
Any other questions? Final thoughts? If not, thank you so much for some of you being very faithful to the event series, for joining us today maybe for the first time. So much thanks to you for kind of joining and having this conversation with us. I hope it's not misinformation. There should be a drink reception when you go out. So if you want to kind of stay a bit longer and kind of have a chat with, like amongst you or with us about any of these questions, we'd be happy if you could join us in the foyer. Thank you so much again for coming.